Hello there, Mr. Sutton here, bringing you the Algebra 2 10.5 lesson on graphing the other trigonometric functions. If you're doing the Algebra 2 CP, this will be a two-parter. Honors will do it all in one shot. And the topic for this one is graphing transformations of tangent, cotangent, secant, and cosecant. So to start things off, we're going to take a look at the parent table and graph of tangent and cotangent. So just to give you a little bit of an immersive effect here, pause the video, go to Desmos, and see if you can use that to fill out this table. And keep in mind some of these values are going to be undefined. And then also use the graph Desmos gives you to kind of sketch one period of each of these functions. All right, let's see how that went. So I'm going to Desmos, the graphing one. So, and part of the reason I'm using the graphing one is because you can't really access the cotan, secant, and cosecant functions very well on the scientific one. You can kind of fake them by doing 1 over the original 3 trig functions, but it's nice to have the original here. But tangent would work either way. But let's do tangent. Let me do f of x equals tan of x. Another thing that's kind of nice about the Desmos grapher is that it defaults to radians mode, so I don't have to change it into radians from degrees. So let me come up with a few of these values now. So we have f of x, let me do f of negative pi over 2. And that comes out to undefined, okay? And I'm going to use this little empty set symbol to signify undefined. Let's do negative pi over 4. And that's going to be exactly -1. And I could figure all of these out just using unit circle trig, but we're just kind of speeding up the process here. And then tan of 0 is 0. Great. Tan of pi over 4 is 1. And then we've got tan of pi over 2, which is undefined. Now, if we zoom in a little bit here, and just to make this a little bit easier to look at, let me actually change my x-axis values. Let's go from, say, negative 2 pi to positive 2 pi. And so if I do that, it looks like this is negative pi right here, and this is going to be negative pi over 2 right in here. What's going on here, it's kind of hard to see because the graph doesn't show asymptotes directly, but there is a vertical asymptote right here, and also right here, and right here. There's actually an infinite number of them, but we're just going to graph one period of this. So pi over 2, that was the last undefined there. So we have a vertical asymptote at negative pi over 2. Then we have the point negative pi over 4 comma -1 right there, 0, 0. Pi over 4 comma 1, and we saw there was another asymptote at pi over 2. And again, just looking at the graph to sort of fill in all those other dots we're not coming up with, we get a graph that looks something like this. It kind of almost looks like a cubic function, but not quite, because cubic function does not have vertical asymptotes. So let's also check out cotan and see what that looks like. And you'll notice that I've got a different set of x values for this parent table because I kind of know where this one is going. So let's do, let's see here, cotan for my original f of x function. Let's do cotan of x, and let's do f of 0, which is undefined. And then we'll do pi over 4, comes out to 1. Pi over 2 is 0. 3 pi over 4 is -1. And then just plain old pi is undefined. And then if we look at the graph, it's the same kind of deal here. So we've got, this is 0 right here. If we go over here, this is around 3.14. You could even graph it just to see. If you put in x equals pi, you'll see that, yep, that's that vertical line that we're approaching, but not quite touching. So we end up seeing that we have a vertical asymptote on the y-axis at x equals 0. We have pi over 4 comma 1 right here. We've got pi over 2, 0. 3 pi over 4, negative 1, and another vertical asymptote going through pi. So we end up with kind of the same graph as tangent, but going down instead. And also the asymptotes are shifted over a bit, but it's the same kind of a graph. So some commonalities we're noticing here for both of these. If we're talking about the domain, we see that we have vertical asymptotes on these places where the x was undefined. And we saw from looking on Desmos that there was an infinite number of those. We also saw that based off of these, our range is going to be all real numbers. We're going up and down forever. So unlike sine and cosine that kept bouncing back and forth between negative and positive 1, these go forever in both directions. And then the last thing, like sine and cosine, these repeated, they were periodic. And we had a period, if you look here, from negative 2 pi to 2 pi, from 0 to pi, that is a period of pi. Whereas sine and cosine each have a period of 2 pi before they repeat. Now that we've seen the parent functions for tan and cotan, we're going to get a little practice graphing one of each. So in each case, we're going to graph one period of the function, because just like with sine and cosine, if you don't stop at 1, then, I mean, where do you stop? And then we also want to maybe just describe the transformation that's going on here. So this is pretty similar to what we did with sine and cosine. You're going to write down your parent table, do whatever the transformation is to the x and the y values, get a new table, and then graph that new table. The one thing that's a little bit different, and you're going to see this with all the functions in this lesson, is that usually 2 or 3 out of the 5 things that you get in your table are actually going to be giving you asymptotes rather than exact points. So with that in mind, pause the video and try this one out. All right, so let's talk about what is going on with my transformations. The 2 outside is giving me a vertical stretch. The 3 inside is giving me a horizontal shrink. And throughout this lesson, you'll notice we're not worrying about vertical and horizontal shifting or translations. We're just dealing with the stretches and shrinks. And there might be a random reflection in there somewhere. So here is our parent table for tangent. Again, we're going from negative to positive pi over 2. And we've got undefined, negative 1, 0, 1, and undefined. So the horizontal shrink means we're going to be multiplying my x values by 1 over 3. And then the vertical stretch means we're doing 2 times the y values. So 1/3 times negative pi over 2, that's negative pi over 6. And then negative pi over 4 becomes negative pi over 12. 0 is still 0. Pi over 4 is pi over 12. And pi over 2 is pi over 6. And now for the y values, 2 times all of these. Well, undefined is still undefined. And then we've got negative 2, 0, 2, and undefined, which is just another asymptote. So I would like my x values to be able to accommodate from negative pi over 6 to pi over 6. And I don't have to do more than going by 1s on the y-axis to get negative 2 to 2. But for the x-axis, I'm going to make these go by negative pi over 12s. That'll give me enough room to show everything here. So we have a vertical asymptote on negative pi over 6 right here. Then we have the point negative pi over 12, negative 2 right here. 0, 0, pretty easy there. Pi over 12, comma 2. And then finally another vertical asymptote on pi over 6. And then you've seen what the parent function looks like, so just do one of these sorts of curves here where you're approaching the asymptotes on the left and the right, and we're going through these 3 points. Next up, we're going to do one of these problems with a cotan function. Pause the video and give this one a shot. All right, so this 1/2 inside is giving us a horizontal stretch. And we've got the parent table for cotan. So that's going from 0 to pi. And we have undefined, 1, 0, negative 1, and undefined. Again, you might want to have these written down somewhere so you don't have to necessarily memorize every little thing, because there's a lot of these parent tables. And then the transformation. So since it's a horizontal stretch, we're going to be doing 2 times x. And there's nothing going on vertically. There's no outside multiplier. So y is just staying the way it is. So for the x's, we've got 0, and then this will become, let's see, 2 pi over 2, so 2 pi over 4 rather, so pi over 2. This becomes just pi because the 2's cancel. Then we have 6 pi over 4, which I can reduce to 3 pi over 2. And then finally 2 pi. And again, the y's are staying the same, so we are still undefined, 1, 0, -1, and undefined. So I think if I go by pi over 2's, I could pretty comfortably fit all my x values, and then just going by 1's for the y values. So we've got an asymptote at 0 here, and then we've got pi over 2 comma 1 right there, pi comma 0, 3 pi over 2 comma -1, and asymptote at 2 pi. And then just draw the curve going through those and approaching the asymptotes. So if you are doing the CP non-honors version of this course, then this is the end of part 1 for you. You can pause the video, get a little practice graphing just tangent and cotangent, and then come back to take a look at our other two functions. Welcome back. If you're rejoining us from the CP version of the course, if you're on the honors, then you're just continuing on. So we've got two more trig functions for you, secant and cosecant, and two more parent tables for you to go with those. So just like we did before, pause the video and fill out these tables using Desmos, and then also use Desmos to help you figure out what the graph of this thing looks like, and we will bring it back together in just a moment. All right, let's do secant. So go into Desmos. Let me clear out all this stuff that's in there already, and let me do f of x equals secant of x. And then let's fill out some values here. So we have f of negative pi over 2 comes out to undefined. And then if I plug in 0, we've got 1. How about pi over 2? Undefined. Wow. How about pi? -1. And then 3 pi over 2. 3 pi divided by 2. Undefined. Wow. How about that? So let's see here. Let me see what this graph looks like overall. And just to make this a little easier to look at, I didn't show you this last time, but this is also kind of neat. If you go to the little wrench here, and we already talked about changing the x-axis and what it's looking at, but you can also change the increments on the x-axis. If I want to make these go by pi's over 2, I'll just write pi divided by 2. And if we go back to the graph, you can see that we are now going by pi over 2. So that actually does make it a lot easier to see where we are. And we can see here, if we're going from just negative pi over 2 to 3 pi over 2, that's kind of this set of graphs right here. We definitely do have some asymptotic behavior, it looks like, and you can see this if you zoom out. These almost kind of look like teeth. So here is a snapshot of our graph. We've got a vertical asymptote at negative pi over 2. We've got the point 0, 1. We've got another asymptote at pi over 2. And then we've got pi, -1. And then we've got another asymptote. And this, we definitely needed Desmos to accurately graph this because one point isn't really enough to tell what's going on. But if you look at Desmos, it looks like we're going through that one point and then kind of turning around and going back. So we're doing this sort of thing, and we're just doing that on two different branches. Now let's see how cosecant compares to this. And this will be an interesting comparison because secant was the reciprocal of cosine. Cosecant is the reciprocal of sine. So, I mean, we know that sine and cosine are just each other kind of shifted over by 90 degrees. So I kind of wonder if we'll see the same thing with their reciprocals. Let's give it a look. So going back to Desmos, I'm going to turn this into cosecant of x. And let me move this so I can see what numbers I'm plugging in. So I'm going to start with 0 this time. And I get undefined. It's almost like they picked the parent table for this reason. And then we've got pi over 2 is 1. And then pi is undefined. And then 3 pi over 2 is -1. That came out undefined last time, but now we've got -1. And then if I plug in 2 pi, that is undefined. And then just taking a look at this graph, which we can see now, it's basically the same as secant, only it's been shifted over. In fact, if you graph them both at the same time, here's the secant graph, and we see that, yes, indeed, just like sine and cosine, these are just shifts of each other. Now, it's also interesting to see how a cosecant relates to the sine function. If we do the sine function, we see that it's basically covering a lot of the stuff that the sine function isn't, and it's got these asymptotes where the sine function was 0, which makes sense because 1 over 0 would be undefined. So putting it all together, here's the graph I'm going to draw. Asymptote at 0, we've got pi over 2, 1. Asymptote at pi, 3 pi over 2, negative 1. And asymptote at 2 pi. So the domain, just like with cotan and tangent, and there's one branch and there's the other branch here. So the domain, we have vertical asymptotes again where x is undefined. And for the range, this is a little different, right? We don't have all real numbers. We're missing everything between -1 and 1. Instead, we have y is less than or equal to 1. We can get all this stuff down here. Or y is greater than or equal to 1. All this stuff up here. And then finally, the period is actually, if you take a look here, it repeats every 2 pi, not every pi like cotan and tangent. So the period is more similar to sine and cosine. So just like before, we're going to do one of each to give you a sense of graphing these. So try out 2 secant of x, pause the video, and give it a shot. All right, so this 2 out here means we have a vertical stretch. Here's our parent table for secant, going from negative pi over 2 to 3 pi over 2. Again, that's a period of 2 pi there. And looks like we've also got the y values to go with it. Now for the transformation, the x is staying the same because there's nothing happening inside. But the y is getting multiplied by this 2 here. So for the x's, we still have negative pi over 2, 0, pi over 2, pi, and 3 pi over 2, just like before. For the y values, we have undefined, 2, undefined, negative 2 rather, and another undefined vertical asymptote. Putting that together, we can just go by pi over 2's, it looks like, for the x-axis. So we have negative pi over 2, asymptote, 0, 2, pi over 2 asymptote, and then pi comma negative 2, and then another asymptote right there at 3 pi over 2. So we have one tooth up here and another one down here. For our final problem, we will do a cosecant graph with a few things going on. Pause the video, give it a shot. All right, so this 1/2 out here means we have a vertical shrink. The pi inside means a horizontal shrink as well because pi is bigger than 1. Here is my cosecant parent table going from 0 to 2 pi, undefined 1, undefined -1, undefined. Now for the g function, for the x values, we're going to be multiplying by 1 over pi, and then for y values, 1/2 times y. So multiplying all that out, 0 becomes 0. Pi over 2, the pi's are going to cancel, so that's just 1 over 2. Pi over pi is 1. 3 pi over 2 times 1 over pi gives us just 3/2. And then 2 pi is going to become just 2. For the y values, we've got undefined, 1/2, undefined, -1/2, and undefined. I can go by 1/2, it looks like, on my x-axis. It's actually the first one, I think, where we don't have a pi going on the x-axis. So we have an asymptote at 0. We've got 1/2 comma 1/2, which is right here. And I made my y values go by 1/2 as well, just to more easily fit those. And then we have a 1 giving us an asymptote. And then 3/2 comma -1/2 down here. And another asymptote at 2. So one tooth up here, one down there, and that'll do it. So this wraps up our lesson on graphing the other trigonometric functions. Until next time, Mr. Sutton, signing off.